Our next special property is that if a diameter is perpendicular to a chord, then it bisects the chord in the arc measure. We can see this, okay? VT is the diameter, so we've got VT as our diameter. We'll go on ahead and mark that. And we know that it is perpendicular to the chord. It is going to, according to this property, bisect our chord. So we've got RW that is going to be bisected, so cut in half, at that diameter at point S. We're also going to do the same thing to our arc measure. So RW is going to be cut in half into two equal pieces, RT and TW. We can use that information when we're solving for questions like we have on the right side. So in this situation, point M is the center. OM, we can see, is 13. Okay, if OM is 13, and this is a right angle, I can use Pythagorean theorem to help me solve for EO. And that will help me because if I can figure out what EO is, then I can figure out what GO is because I know that these two things are going to be congruent to each other. So by solving for X, by X squared plus 5 squared equals 13 squared. Once I figure out X, I can multiply it by 2 because I have two of them to figure out what GO is. Okay, so let's start out. X squared plus 25 equals 169. I can subtract 25 from both sides. X squared equals 169 minus 25. It's going to be 144. And then I can take the square root of that. Square root of 144 equals 12. And if X equals 12, so EO equals 12, GE also equals 12. And so if I add those together, GO is going to equal 24. Down here, circle E has a radius of 19. So we have 19 as our radius. We're trying to find the value of X. So I know that X squared plus 5 squared equals 19 squared. X squared plus 25 equals 19 times 19. That's the same as 19 squared, 361. Subtract 25 from both sides. X squared equals 336. And then if I take the square root, X is going to equal square root 336. We have 18.33. We've got all those numbers out beyond. I'm going to round it and say it's approximately 18.33.